Hi, welcome to our first lesson. The first thing you need to do is make sure that you have your student journal. I need you guys to tear out pages 1 through page 32. So go ahead and do that right now. Pause the video while you're tearing it out. Once you do that, we're going to begin with our very first lesson. Now, don't forget, make sure you write your name on every single one of the pages in the journal. So I'm going to put Mr. Asuna, you put your name. Now, the very first lesson that we're going to do is lesson 1.1, which deals with points, lines, and planes. Now, we're not going to start in the exploration page. What we're going to do is we're going to talk a little bit about a few definitions. So for that, I need you to turn to page 4. No, 5, sorry. So turn to page 5. Okay, so go ahead and read these definitions with me. The first definition has to do with undefined terms. Okay, kind of like making up the rules to a game. Now, a point has no dimension and is represented by a dot such as this one. Now, what I mean that has no dimensions, it means that it doesn't have a size. There's no such thing as one dot being bigger than the other dot. So all points are pretty much the same. They just describe a location. The next thing we have is a line. A line has one dimension. It is represented by a line with 2 arrows, but it extends without end. Here you can see an example of a line. It has 2 arrows going to the left and going to the right. Notation is going to be key, and we're going to talk a little bit about notation in just a bit. Now, through any 2 points, there is exactly one line. So through any 2 of these points, there can only exist one line through it. You can use any 2 points on a line to name it. So we're going to talk about how to name points in just a bit. The next thing we have is a plane. A plane is a 2-dimensional figure. It is represented by a shape that looks like a floor or a wall, but it extends without end. Now, if you look at this diagram looks like it's a parallelogram. And parallelograms have actually finite distances, but in a plane, the plane is infinite, meaning that the surface of this plane extends to the left, to the right, to the top, and to the bottom. And we're going to talk about naming planes in just a bit. Through any 3 points not on the same line, there is exactly one plane. And these will make a little bit more sense once we start doing some diagrams. You can use these 3 points that are not all on the same line to name a plane. Now, while we're on this page, please go ahead and write down number 1 here. This is going to be for our first example. This is on page 5. That way you know where the examples are going to go. Now, if I go a little fast, make sure you guys pause it, go back and review the video again. Now, defined terms. These are terms that we are going to use using these previous definitions. Okay, the first one, the definitions below, seconds and rays. The definitions below use AB written as AB and points A and B. So this right here happens to be a line. It has points A and it has points B. We're going to use this to name all of these right here. The first one is the segment. The line segment AB or segment AB can be written as AB with a little line at the top. If you do not put the line at the top, it means the distance of that segment. And it consists of 2 endpoints, which in this case is A and B. Okay, and all the points that are in between those 2 that are not named. Note that AB can also be named BA. So direction of the letters doesn't really matter when you're naming a segment. The next thing is with array AB. The array AB, you can write it as AB. Now I know it's kind of small here, but there's actually a small little arrow right above that B. Consists of the endpoint A, so A where there is no arrow, and B where is the arrow. So on AB, that line on the same line of A and B. For example, this is array A, B. Now, if we were to switch the order of the arrow and make it start on B and heading towards A, then the notation would look a little different. We're going to talk a little bit more about this in just a bit. Now, opposite rays. If point C lies in a line between A and B, then you have created two rays, rays CA and CB. Okay, so you have the ray going from C in the direction of A and from C in the direction of B. Now, because this does form a straight line, we say that CA and CB are opposite rays. Just because they have the same endpoint does not mean that they're always going to be opposite rays. So pay very close attention to that. Now, at the bottom here, you're going to put example number 2 right there. Okay, so while we're there, please go back to page 4. Now, on page 4, I just want you to write down where the problems are going to go. So on page 4, number 3 is going to go right there next to the word undefined terms, and this is where you will be writing down the examples that I am doing. If you do not have enough space, feel free to use a separate piece of paper, and simply when you submit the assignment to me, just take a picture of it. Make sure the section number's on it. Problem 4 goes right next to coplanar points. Normally we start with the exploration, but sometimes we're going to start with a little bit of definitions and then go back to the exploration, which is what we're going to do today. All right, please turn back to page 2. Now on page 2, we're going to talk a little bit about the diagram that's going on here. I'm going to try to zoom in a little bit so you can see the diagram a little bit better, but you have that in your journal. Okay, so the very first thing you see here is point A. So how do we call it? Simply point A. Well, what do you see next? You see this, it's a segment. It is finite. It means it only has a specified distance. So we call that segment BC. But what we have to do is we have to put a line above it so that we call it so that it's a segment. If we don't put a line above it, then this right here represents the length of that segment. And no arrows because this is not a line or array. Now this one is indeed a ray because it has an endpoint. It goes towards the direction of G and it continues. We can't see it here, it got cut off, but there's a little arrow continuing that way. So we call this one ray FG. Now the notation for that, the endpoint starts at F and goes in the direction of G. So you put a little arrow above the G. Now down here, you see 2 points, DE, you see that segment, but you can see that the line goes beyond the boundaries of E and D. So in this case, it's going to be a line. So there is an arrow here that we do not see. So this right here is called line DE. And the notation for that is very simple. It's a line with 2 arrows, one going towards D, one going towards E. Now, since we're talking about points, let's talk a little bit about collinear and coplanar points because these words are going to be coming up quite a bit. Let's talk a little bit about points. How do points relate to each other? Okay, so the first thing is points can be collinear. Okay, that just means that the points lie in the same line. Okay, so for example, I'm going to put a little diagram here on the right hand side. 3 points are collinear. If you have a line, here's 1, here's 2, here's 3. Here's an example of 3 points that are collinear. They all lie in the same line. Now, the other one obviously is non-collinear. Now, non-collinear just means that they're not on a line. You cannot create a line going through any of those 3 points. Now, the next one is the word coplanar. Now, we're going to talk a little bit about planes in just a bit. Okay, so the word coplanar just means that they're in the same plane. So if I were to draw a plane like this, I draw 3 points that are coplanar. So if one of those points is not on that plane, they're obviously going to be called non-coplanar. So know the difference between collinear, non-collinear, coplanar, and then the last one, like I mentioned, non-coplanar. So this one's easy because all you got to do, draw a plane, draw 2 points on it, and then I'm just going to draw a point outside the plane. So those 3 points are non-coplanar. So please know the differences between all 4 of these. Now, what about lines? Let me zoom out a little bit. Okay, so down here at the bottom of page 2, we're going to draw the 3 different scenarios for how lines interact with each other in a plane. Okay, so all these lines, they're all in a plane. So what happens if 2 lines do not intersect? Well, the 2 lines are said to be called parallel. Okay, but we're going to talk about parallel a lot in the future. But let's just draw the diagram and talk a little bit about the notation too. So here you have 2 lines that do not intersect. Okay, they have a total of 0 intersections. And in a diagram, if you look for 2 arrows going in the same direction, but not the arrows at the endpoints, but the arrows that are in the middle, that means that these 2 lines are parallel, therefore they will not intersect. Now, lines will intersect. How many times? 1 time. Oops. So here they intersect, boom, only 1 time. So they get 1 intersection. Now the next one is a little bit hard to grasp, but it's actually an infinite intersection. If you have, say, this line right here, and then you draw another line that I'm going to draw the line in green in a highlighter, but it's going to be a line that's going to go right above that same line. Well, the green line and the pencil line, they intersect everywhere on this line. So we say that these have an infinite intersection. So they intersect an infinite amount of times. Okay. All right. Now, so far things have been pretty easy, but it's gonna get a little bit more challenging in the next page because we're gonna start drawing a little bit about planes and lines and how they interact with each other. So please turn to page 3. All right. So how does a line and a plane interact? Well, they interact in 3 different ways. The line is either on the plane, not on the plane, or simply intersecting the plane. So let's look at all 3 of the scenarios. Okay, let's look at the one where the line is in the plane. So I'm going to draw 3 planes here. And how do you draw a plane? It's like drawing a little rhombus or like a parallelogram. So draw 3. Okay, so let's start with the line on the plane. Okay, so I'm simply going to draw a line on the plane. I'm going to call that line L, and I'm going to call the plane P. And by the way, you can name a plane using any three non-collinear points. Okay, so here, L is on the plane. How many times does the line intersect the plane? An infinite amount of times. Okay, so L is, oops, L is on the plane. Whoa, sorry, cannot see that. It's hard to manage a computer and this at the same time, so sometimes this thing will slip and you can't see it. Okay, so in this one, L is on the plane. Well, in the next one, the line is not going to be on the plane. So it's a line that's going to be kind of hovering. So you kind of have to use your imagination. Imagine this being a flat surface, and then this having the line going right through it. Kind of like if you have your paper and you have this highlighter. Obviously, the highlighter is not on the paper. It's just hovering over it, so it's not intersecting the paper. So if you draw a line kind of like this, now, even though this looks like it's intersecting here, it's not. It's actually hovering over it. So here, L is not on the plane. And for our third one is the line intersecting the plane. So the way to do this is really simple. Draw a line coming from outside the plane to a specific point, and then you're going to draw little dashes right behind the rest of the plane. Then once it's exposed, you can draw little arrows. It's kind of like having a piece of paper and stabbing it with a pencil, and then having the pencil be right in between it. So here, this line L intersects plane P. Okay, so here L intersects the plane. Okay, so what about planes themselves? Planes can either intersect or not intersect. So if the planes do intersect, we're gonna have a bit of a hard time drawing that, but I'm gonna show you guys how planes do not intersect, and that's a way easier diagram. So let's look at what happens when planes are parallel. All you gotta do is simply draw a diagram, draw the parallelogram, one below the other. And let's call this plane P and plane Q. They're not intersecting, so here we say that plane P is parallel to plane Q. Now this next part, we're going to practice this twice. It's going to be one of our examples. How do you draw two planes that intersect? And it's not really that easy to do, to be honest. So the way I like to do it is I like to draw a plane, just like I always do. That part's easy. Then draw a plane going kind of vertical. So I'm going to draw one like this. Now here's the thing. You see that intersection right here? Put a line right through that. And that's going to be the intersection of the plane. So say you have plane P and plane Q. The two planes intersect at this line. We're going to call it L. Okay, so we are pretty much done with the lesson. We are going to proceed to the 4 examples that I already told you where they were going to go. Okay, if you don't remember where they were going to go, I'll tell you really quickly right now. Okay, problems 3 and 4 are going to go on page 4, and problems 1 and 2 are going to go on page 1 and on page 5. So let's start with the first one. Sorry, my kids like drawing on my things. All right, so here's the first example. Okay. Before I start the example, make sure you guys pause the video, draw the diagram exactly where I told you guys it was going to go, and then go back and play the video so you can see how I'm doing the example. It says, give two other names for line PQ and plane R. So here's line PQ. How can I name this line? Well, the very first one that you notice, if you see that little lowercase letter right next to the line, that means that you can name this line using that lowercase letter. So we can call this line N. Now, line PQ can also be written the same way, but you can reverse the order of the letters. So I can call this line QP. And you got to make sure you put the arrows. Otherwise, they're going to be segment lengths or segments, depending on how you did it. Now, how else can you name plane R? You notice that R right here does not have a point next to it. So it's not a point. Now, we did talk about the fact that you can name a plane using three non-collinear points, and there's a variety of answers you can use here. So you have to use 3 points that are on the plane, but are not on the same line. So for example, we're going to have to use letter V for sure. Now I got the option of using either S, P, or T. I have to use both of them. I cannot use M because M is not a point. M is the name of this line. So I'm going to call this plane, I don't know, order doesn't really matter, VST. That's one example. There's more examples, but that's the one I like. Now it says name 3 points that are collinear. Remember, collinear means that they're on the same line. So here's easy, S, P, and T. Easy. Those 3 points are collinear. Name 4 points that are coplanar. Coplanar means that they're on the same plane. So if you look at the diagram, look for 4 points that are on the plane. It's very simple. Look, T, P, S, and V. I cannot use Q. Q is not on the plane. So S, E, T, and V. Those are the 4 points that are coplanar. So that's example number 1. Let's look at example number 2. Naming segments raised and opposite raised. Okay, so give another name for segment GH. Remember, you can reverse the order of the letter. Should have named these. Okay, so GH, reverse the order, H, G. Now, am I done? No, because if I just leave it like that, I'm talking about the distance of that segment. So you have to put a line above it because we're calling it a segment. We're not talking about its length. That's coming later on. Name all rays with endpoints J. Okay, well, where's J? J is right here. Now, even though there is no point, anytime there's an intersection of 2 lines, you can assume that there's going to be a point right there. So how many rays do you have? We have 1, 2, 3, and 4. So you have JE, you have JG, you have JF, and you have JH. So those are the 4 rays that you have. Now, of these rays, which of these are opposite? Well, here's the thing. These are collinear, so these 2 and these 2. So JE and JF. So JE and JF, and the other ones are JG and JH. So these are the 2 pairs of rays that are opposite rays. And that takes care of example 2. Now, if you feel like I'm going a little fast, pause the video, go back and replay it again. Let's move on. All right, I hope you like drawing because this one's going to be a lot of drawing. All right, so it says sketch a plane and a line that is in the plane. So first thing you got to do is you're going to sketch a plane. That's easy. Sketch a plane, draw a little parallelogram, kind of like a square on the side. Now, a line that is in the plane. Okay, well, draw a line on it. Now, you got to put little arrows on it, otherwise it's not a line, it's a segment. Now, it looks a little boring, so let's add some letters. Let's call this plane, I don't know, P, and this line L. So the line is on the plane. That's easy. Let's look at the second one. Sketch a plane and a line that does not intersect the plane. Oh, cool. Here's a plane, call it P, and a line that is not intersecting the plane. That means it's parallel to it. So I'm going to draw a line right there. Call it out. And then for the third one, sketch a plane and a line that intersects the plane at a point. So draw a plane. I always suggest pick a point somewhere on the plane and then draw a line coming from outside the plane to that point, but don't draw the line going straight through it. Draw little dashed lines up until the boundary of the plane. And then from here you can actually do a solid line. So here's plane P being intersected with line L, and at this point, you can call that point whatever you want. You can call that point A. Okay, so that's example number 3. Now, what I will be doing is I will be using my Cam Scanner app and take pictures of these examples and upload them to Teams so you guys have full access to those examples if I went a little too fast. All right, let's look at example 4 now. Okay, last example. Sketch 2 planes that intersect in a line. Now, I wrote down here part of the steps. Okay, so let's go through them. So draw a vertical plane. Okay, well, let's draw a vertical plane. Do the best you can. These are not that easy to draw, especially this one. Draw a second plane that is horizontal. Okay. Okay. Use dash lines to show where one plane is hidden. Okay, so then draw a line of intersection. Intersect right there. There you go. Plane P, plane Q, line out. All right. Make sure you guys do all the extra practice examples and see y'all later.